Digital trust is not one size fits all. PKI proves who you are. KSI proves data existed unchanged at a point in time. Blockchain coordinates shared trust without a single controller. In this module, the goal is to choose the right mechanism for the trust problem in front of you. We've now built three lenses on digital trust: PKI for identity, KSI for scalable integrity, and blockchain for anchoring evidence. Next, we move from understanding each mechanism to selecting between them. What problem are we solving, and which trust model fits best? Before comparing PKI, KSI, and blockchain, separate the trust question from the technology. If the question is, who created or approved this, identity matters. So PKI and digital signatures are usually the right model. If the question is, has this data changed since a known time? Then integrity proofs, timestamps, and hash chains are central, which is where KSI fits. If the question is whether many parties can verify a shared history, blockchain becomes relevant. Legal recognition is a separate issue. It depends on governance, regulation, and trusted service frameworks. PKI answers a simple but critical question: who owns this public key? A certificate authority verifies an entity and issues a certificate that binds that identity to a public key. Relying parties use the certificate chain to decide whether to trust a website, signed document, code package, device, or email sender. The system is only as strong as the authority behind it. Validation rules, policies, revocation, audits, and operational security. If that governance is weak, the trust chain is weak too. KSI begins by reducing each record to a hash, a compact fingerprint of its exact contents. Instead of signing every object with a private key, KSI aggregates those hashes into a tree, producing one root value that represents many records at once. That root is linked into a time sequence and eventually published, so the evidence can be checked independently later. If even one bit changes, the hash path no longer matches. The boundary is authorship. KSI proves data existed unchanged at a time, but not who created or approved it. Blockchain is best understood as a shared, append-only history, verified by many participants instead of one owner. Transactions are grouped into blocks. Each block receives a hash, and that hash links it to the previous history. Consensus determines which version is accepted, and copies are replicated across the network. This is useful for asset ledgers, token workflows, decentralized applications, and anchoring outside evidence to a time-stamped record. But trust is not automatic. It depends on validator incentives, governance, and how decentralized the operation really is. These are complementary trust tools, not competitors. PKI answers, who is this and can I trust their signature? KSI answers, did this data exist at this time and has it changed? Blockchain answers, can multiple parties agree on a shared history? Mature architectures often combine them: PKI for identity, KSI for evidence, and blockchain for shared verification. When evaluating a trust technology, ask what claim the proof actually supports. A PKI signature links specific data to a private key tied to a certified identity. KSI proves a hash was included in an integrity process, showing the data has not changed since that time. A blockchain record proves a value was written into a ledger at a block or approximate time. None of these automatically proves legal validity. That depends on governance, policy, identity assurance, and the jurisdiction accepting the evidence. At first glance, these ecosystems can look similar. They can all help prove when something existed, show it has not changed, or preserve evidence for review. The difference is the evidence model. PKI relies on certificate authorities and their policies. KSI relies on aggregation, hash proofs, and publication. Blockchain relies on block inclusion and consensus rules. So the practical question is not which one timestamps. They all can. The better question is, what must the verifier trust for this proof to be convincing? A blockchain can prove that a key signed a transaction, or that an event was anchored at a certain time. That is not the same as proving who the person, device, or organization really is. By default, a wallet address is pseudonymous. PKI adds identity proofing, certificate policy, CA validation, revocation, and accountability. That is why TLS, code signing, enterprise logins, device certificates, and legal signatures still rely on PKI. In practice, blockchain can preserve evidence, but it does not replace the identity trust framework. A KSI stamp is strong evidence, but it answers a different question than a legal signature. It can show that data existed at a certain time and has not changed since. It does not by itself prove who approved it, whether they intended to sign, or whether the process meets eIDAS or other legal requirements. For an audit log, KSI is excellent for integrity at scale. For a contract, you still need verified identity and signature compliance. When both are required, use KSI with PKI signatures. Decentralization is useful, but it solves only one part of the trust problem, reducing dependence on a single operator. Regulators ask different questions. Who is accountable? Who is liable? Which jurisdiction applies? How are audits, certifications, revocation, and disputes handled? A technically distributed service can still fail regulatory expectations if governance is vague or controls are undocumented. The design lesson is straightforward. Combine decentralized architecture with clear policies, assurance processes, legal recognition, and operational accountability. Trust comes from the full framework, not the network topology alone. Start with the trust question, not the technology. If the problem is proving who signed, who connected, or who is allowed access, PKI is the natural fit. If the problem is proving that large volumes of records have not changed over time, KSI is often better. If independent organizations need a common evidence layer, blockchain can help. When the system needs identity, integrity, timestamps, and cross-party auditability, use a hybrid. Also check governance, legal recognition, performance, and threat model. The right mechanism is the one that answers the actual verification requirement. In real digital trust architectures, these technologies are layered rather than treated as rivals. PKE answers who or what is acting and whether a signature is attributable. KSI answers whether data existed at a specific time and has remained unchanged at scale. Blockchain is used selectively to anchor important evidence or state changes into a shared audit environment. Governance makes the whole system usable in court, regulation, and operations. The design principle is clear: identity first, integrity next, distributed audit where needed, and policy across everything. That is how hybrid systems create practical digital trust. Remember the core distinction. PKI establishes identity and authenticated signatures. KSI proves integrity and time, and blockchain supports distributed auditability and anchoring. They can overlap, but their evidence is not interchangeable. Using one as a substitute for another creates risk. Next, we look at post-quantum threats and how these trust architectures must evolve.